Apologize for my mic issues. Hopefully I'll have that resolved and have a chance to go back and redo these. 3 big lessons for today out of here. So number 1. Okay, we need to interpret R. You know what? I need to put something under here quick. Joys of permanent markers. Okay, so to interpret R, what you need to worry about there is much like when we were talking about scatter plots, is you need to know the direction. Are we positive or negative? Your form is always going to be linear. Okay, we're comparing it. R always is assuming that you're doing things in terms of linear fashion. So, okay, always, 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 always. In terms of your strength, okay, -1 and 1, +1, are going to be your strong correlations. 0.5, a -0.5 and +0.5 are going to be moderate. And then 0 is going to be weak. Okay? And then for number 2, about correlation in general. Correlation. First of all, R doesn't have units. It is a constant. Okay? So that constant there is going to just tell you kind of how strong the relationship is between the two. And that's all. If you switch axes, it's not going to change anything. Because the relationship is still going to be the same. We're going to kind of talk about a little bit more how that works. And then it's non-resistant. And we saw that when we added in that outlier. So outlier is in the pattern. Strengthen it. And outliers outside of it. Weaken it. So that's why we don't do that. That's why, and we saw that. We saw the one way off up on the side that made the correlation stronger. We saw the one down below, and that made it weaker. Okay? And this is probably the most important thing. Number 3. Correlation does not equal causation. Okay? Just because there's a relationship between the two doesn't mean that one is causing the other. And we'll see that in the next example. We're going to skip this one down here. It's kind of a duplicate. Take a look at this. We are going to look at chocolate consumption and does it make you smarter? So we have the number of, cross down over here, the amount of chocolate consumption of kilograms per year per person. Sorry, lost the cap to my pen. There it is. Important things, I know. And we're going to compare it to the number of normal, so that's per person in the various countries. And then we're going to compare that to the number of Nobel laureates they had, which is, again, the number of Nobel prizes per 10 million people that they have in the country. So that way we kind of scale it to make it safe, make it the same. Okay? So notice down here, China doesn't eat a lot of chocolate. They don't have a lot of Nobel laureates. France eats probably about 6 or 7 kilograms per person of chocolate, and they average 10 per every 10 million people. You got the UK over here. which is probably about 9 kilograms of chocolate, and they're almost up to 20 Nobel Prizes per 10 people, or 10 million people. So, you know, there seems to be some sort of relationship. And here, notice that with a correlation of 0.791, it's pretty strong. Okay, so in terms of the interpretation here, we would say there is a moderately strong positive. Why positive? Because we're going up. Correlation. You can also say that from the number because the number is positive. Correlation between, what are the two things we're trying to set up? Chocolate consumption and Nobel winners. Now, do you really think that the more chocolate you eat is going to, if we had everybody in the United States increase their chocolate consumption so they're a little bit higher than 5, if we had everybody eat twice the amount of chocolate, that we'd get more Nobel Prizes? Probably not, right? Oh, look, right there. So can we go ahead and do this? Like, no. Simply no. Correlation does not mean one variable can change the other. What it does mean, there is something else impacting. Both variables. Like economics in the countries. Take a look at the countries up here in the upper right. Sweden, Denmark, Austria, Norway, United Kingdom, Switzerland, Germany, Ireland, United States, France, Finland. All of those tend to have fairly strong educational systems, for one. Two, they tend to be they're all in the Western European, Western hemisphere. So there's that aspect of it. They tend to, have fairly strong economies, which will then allow a whole bunch of other things to happen. So that would be one, you don't have to worry about as much. So because of that, that is probably a strong reasoning for what's going on there. What effect does Switzerland have on the correlation? Switzerland falls pretty much in line with what's going on. So you would say something to the effect of it strengthens the correlation since it follows the linear pattern. Now again, remember, linear pattern is kind of a general sense. They're not all falling on a straight line, but what we need is kind of like, okay, if we set up we set up two fences, is everything kind of staying within those two fences in those cases are. Sweden probably isn't helping them a lot, but you get the general idea. Okay, so hopefully that helps you with correlation. We'll see you back here for more on if Barbie's going to be safe.